Welcome to the DIY Honda Garage channel. The DTC P0718 indicates an intermittent failure of the input shaft main shaft speed sensor, primarily responsible for measuring the rotation speed of the input shaft in the automatic transmission. This sensor plays a crucial role in sending crucial information to the Engine Control Module, ECM, or Powertrain Control Module, PCM, which helps in controlling transmission shift timing and overall vehicle performance. Located near the transmission on the main shaft, any disruption in its functioning can lead to a multitude of issues affecting vehicle operation. This DTC specifically points towards an electrical circuit problem rather than a mechanical fault within the transmission itself. Therefore, diagnosing the electrical connections becomes imperative. Be sure to reference and record all pertinent diagnostic information from the Honda Diagnostic System, HDS. Before proceeding to troubleshooting, the input shaft main shaft speed sensor is an essential component of the Honda CR-V's transmission system, primarily responsible for monitoring the speed at which the input shaft rotates. This information is critical as it allows the PCM, which acts as the brain of the vehicle's engine management system, to determine when to engage or disengage gears, ensuring optimal transmission performance. Located on the main shaft of the transmission, this sensor has a direct impact on the overall efficiency of the vehicle. In the event of an intermittent failure, the sensor will generate the DTC P0718, indicating that the PCM is receiving erratic signals regarding the input shaft speed. This disrupts smooth operation and may lead to shifting issues, affecting overall drivability. The underlying cause of this DTC is typically traced back to electrical issues within the sensor circuits, rather than mechanical failure within the transmission mechanism itself. The potential causes for the DTC P0718 include various electrical circuit problems rather than mechanical failures. One common issue is poor connections or loose terminals in the input shaft main shaft speed sensor circuit. When the connection is not secure, the sensor may not relay accurate readings to the PCM. Additionally, a damaged sensor itself can also be a direct cause of the intermittent failure. Wiring issues, such as frayed or broken wires, can introduce resistance or complete interruption in the circuit, leading to inconsistent sensor performance. Properly diagnosing and identifying these issues is critical in accurately resolving the DTC and restoring the vehicle to its normal operational state. Sometimes, it may require inspecting the wiring harness for signs of wear or shorts as well. The symptoms associated with the DTC P0718 can mimic a variety of other vehicle issues, but are predominantly focused on transmission functionality. Drivers may notice transmission shifting issues, such as harsh or delayed shifting, that can significantly affect overall drivability. Erratic RPM readings may also be observed on the vehicle's dashboard, as the PCM struggles to accurately gauge engine performance due to compromised sensor input. This can further lead to broader engine performance problems, including stalling or jerking behavior while driving. Additionally, the check engine light will often illuminate, signaling that a diagnostic trouble code has been detected, prompting the need for immediate attention. It's vital that any of these symptoms are addressed promptly to avoid further complications or damage to the vehicle's transmission system. The first step in addressing the DTC P0718 involves verification of the problem. Begin by turning the ignition switch to the on position, which is the second position in the ignition cycle. Immediately, proceed to clear the DTC using the Honda Diagnostic System, or HDS. which is a specialized tool designed for conducting diagnostic tests on Honda vehicles. Next, safely raise the vehicle using a lift, ensuring it is securely supported to prevent any accidents. Allow the front wheels to rotate freely to facilitate the next step. Start the vehicle engine and disable the Vehicle Stability Assist, or VSA, system by pressing the VSA off button. The vehicle should then be run at speeds exceeding 12 miles per hour, or approximately 20 kilometers per hour, while monitoring the input shaft, main shaft speed, and output shaft, countershaft speed using the HDS. It is essential to compare these two speeds to determine if they are about the same, which can help indicate whether a failure is present. In the second troubleshooting step for diagnosing the DTC P0718, begin by turning the ignition switch to the lock position, effectively shutting down power to the vehicle systems. Subsequently, disconnect the input shaft, main shaft, speed sensor 3P connector. It's crucial to ensure that this connector is free from dirt and corrosion to obtain accurate measurements. Next, turn the ignition switch back to the on position without starting the engine. After doing this, proceed to measure the voltage between test points 1 and 2 as specified in the diagnostic guidelines. Test point 1 will be connected to the number 3 terminal of the input shaft, main shaft, speed sensor 3P connector, while test point 2 should connect to a solid body ground. Ideally, you should be measuring around 5 volts. If you obtain this voltage, it indicates that the VCC2 wire is functioning correctly, and you can safely move on to the next troubleshooting step. Should the voltage be absent or significantly lower, you will need to repair any breaks in the VCC2 wire between the sensor and the PCM before proceeding. Moving on to the third troubleshooting step for DTC P0718, you will again start by turning the ignition switch to the lock position. This is important to ensure that the vehicle's electrical systems are at rest, thereby making the disconnection process safer. Once the ignition is in the lock position, proceed to measure the voltage between the designated test points while the input shaft, main shaft speed sensor 3P connector remains disconnected. The focus will now be on the NM, neutral or main shaft line. Connect test point 1 to the number 2 terminal of the sensors connector, and test point 2 should be grounded. Additionally, ensure that the ignition switch is in the on position for accurate voltage measurement. The expected voltage should again be around 5 volts. If this reading is obtained, proceed to the fourth step in the troubleshooting process. Conversely, if the reading is absent or significantly lower, it suggests issues within the NM wire that need to be addressed. The fourth troubleshooting step for DTC P0718 requires you to return the ignition switch to the lock position. This ensures that all electrical systems are powered down. The next action is to check for continuity in the SG2 line, which is another critical wire in the speed sensor circuit. You will need to carry out this test with the input shaft, main shaft speed sensor 3P connector still disconnected. Using a multimeter, check for continuity between the test points defined in the diagnostic guidelines. At this point, test point 1 should connect to number 1 terminal of the speed sensor connector, while test point 2 is again grounded. Your measurements should indicate whether there is electrical continuity through the SG2 wire. If continuity exists, this means the wire is functioning properly, allowing you to progress to the next troubleshooting step. However, if no continuity is detected, repairs will need to be made to fix any open circuit in the SG2 wire, followed by a verification to confirm effective repairs. The final troubleshooting step focuses on inspecting the NM line for potential short circuits. Begin by ensuring that the ignition switch is in the lock position for safety. Next, you will need to jump the SCS line using the HDS, which is essential for this test procedure. Disconnect the PCM connector B to provide access for testing. With the input shaft, main shaft, speed sensor 3P connector, and PCM connector B disconnected, measure continuity between test points accordingly. Test point 1 corresponds to the number 2 terminal of the input speed sensor connector, while test point 2 should be a solid ground. If continuity is present, it indicates that the NM wire is shorted to ground, necessitating repairs. However, if there is no continuity, it points toward an open circuit in the NM wire that must be addressed before concluding the diagnostic process. Once repairs are made, it's important to verify that the DTC has been cleared and that the vehicle operates normally. In the final repair verification step for DTC P0718, it is vital to ensure that all connectors are reconnected properly. Specifically the input shaft, main shaft, speed sensor 3P connector, and the PCM connector. Turn the ignition switch back to the on position to re-establish electrical connectivity. Following this, utilize the HDS to clear the DTC. This step is essential to confirm that the repairs you have made have rectified the issues indicated by the code. Once the DTC is cleared, start the engine and make sure to disable the VSA system once more, as previously done during troubleshooting. Drive the vehicle while maintaining speeds over 12 miles per hour, 20 kilometers per hour, and monitor the input and output shaft speeds using the HDS. It is crucial to determine whether these speeds are now nearly equal. Achieving this parity indicates that the system is functioning correctly, and the DTC P0718 diagnosis can be considered resolved. To prevent future occurrences of DTC P0718, engaging in regular preventive maintenance is crucial. Start by scheduling consistent inspections of the wiring and electrical systems related to the input shaft, main shaft, speed sensor. Over time, wear and corrosion can lead to poor connections that cause intermittent failures. Thus, monitoring these areas will save you from extensive repairs down the line. Ensuring that all connections are clean and secure will significantly reduce the risk of electrical issues. Additionally, regularly check the performance of the sensor and surrounding components to catch any anomalies early. When replacing any parts, make sure to use high-quality OEM original equipment manufacturer replacement parts to ensure compatibility and reliability. Adhering to these preventive practices can greatly enhance the longevity and efficiency of the vehicle's transmission system. In conclusion, DTC P0718 signifies an electrical issue linked to the input shaft, main shaft, speed sensor, rather than a mechanical fault within the transmission. Understanding the sensor's essential role in facilitating proper gear shifts and overall vehicle performance is crucial for effective troubleshooting. As we identified, pinpointing the cause often involves a detailed examination of electrical connections and wiring integrity. Problems such as poor connectivity or damaged wires frequently surface as common culprits. Once identified, appropriate repairs must be carried out, followed by verification to ensure the problem has been fully resolved. Emphasizing regular maintenance and inspections will help mitigate the risks of similar issues arising in the future, thereby preserving the performance and lifespan of the Honda CR-V's automatic transmission system. Please like and subscribe to the channel. See you next time.